Everyone, welcome to day 7 of Intro to ML in Python, and I hope guys you are more excited to work on what project we are gonna do for this day. And guys, before that, don't forget to fill in the attendance form of this day, because based on this and the project only, you will be getting the completion certificate, right? So I hope you guys have enjoyed the 6 days long journey, and this is the last day of our bootcamp. And hope you guys have learned something new in Python and machine learning. And today's agenda is we gonna go through various stages which were discussed in day 5 and day 4, day 5 and day 6 of the Intro to ML sessions. Here we're gonna follow all the things and then put together and work on a project. So the agenda is about data acquisition and exploratory data analysis, feature engineering, model training, model validation, and model selection. And our project name is, guys, the medical cost prediction. Our aim is to predict the cost more accurately. And the data source we have taken is from the Kaggle data source. And Kaggle is, for those who don't know what Kaggle is, like Kaggle is a website where we have many kind of repositories of data, so which can be used for our learning purpose. So before even getting into machine learning, it is always eminent to learn what the columns are present in the data, and what are their what that column actually means. It must not be an intuition like, okay, age is something like what I know. It's all about what the data is ought to be, right? So it is not about any kind of assumptions. It is all about we need to thoroughly learn what the columns are, what it stands for. And it is very much important for feature engineering part to categorize whether it's a categorical or numerical variables. And there is also a set of functions that we might be doing, like label encoding for categorical variables. So guys, don't get thought like, okay, I'm just bombarding with some terminologies, and don't worry guys, we'll be encoding each and every algorithms or each and every steps that are involved in machine learning. And guys, these are the columns that we have for our data set, which is age, and then the sex, which is the gender, and the BMI, which is the body mass index, which has been calculated based on these formulas. And then we also having what is the ideal things and other things. And this is what children, it's like basically the count of children that covered by the health insurance. And the smoker, whether he is smoking or not, like it's kind of yes or no. And then the region, it's about where the person is staying. And the charges is the individual medical cost billed by the health insurance. Okay guys, by just going through this itself, we can find out what are the features and what are the target attribute. So as our question says, it didn't ask for the medical age prediction, it asked for cost prediction. From the scenarios and the data sets, we could find like this is our target variable and these are our feature variables. And it need not to be like all the variables must be a feature variable. And we shall reduce the features and then play among the features to better understand which feature influences the most or the target, right? So getting into our first part, which is data acquisition, guys, unlike this scenario for this project, the data acquisition part itself plays a major role in machine learning. So in our scenario in this project, we got kind of easily from the Kaggle data repository. But in real life scenarios, the data acquisition part itself takes a 2 or 3 days long. Sometimes the data might be in different tables. We might be scrapping from different tables and putting all together in a single table, and then extracting the table, given it is in a SQL database or PostgreSQL or whatever the DB it might be. Or sometimes we might be scrapping from base, all from base from a website, and then working on it, right? So this is how data acquisition part itself. But for now, for our simplicity, for the we have taken the data we have downloaded from the Kaggle data source. So once the data is acquired, the first part of doing is reading the data set, right? So let's hope on with that. Okay, so this is our Jupyter notebook. And guys, so I'll be creating a new notebook, Python 3, and let's have the name as prediction of medical cost. And I'm just gonna start with importing. Okay, before that, data acquisition. This is just for presentation, guys. Like, it's not necessary always to go for a markdown and then go for a code, but it comes of it's just one of the way to present things more better. So I'm just gonna import pandas as PD and import warnings to ignore some kind of warnings along our way. Warnings dot filter warnings, and I'm just gonna ignore. And our first work is to create a data frame called data and store the data from the CSV file. And we all know like what the CSV file name is. The name is insurance.csv. So insurance.csv. And once we have, we must know what are the number of rows and number of columns. For that we use the data.shape, and totally we have around 1338 rows and 7 columns. And along with that, if we are going for data.head, we will be getting the first 5 rows, right? So from this itself, you can come to an understanding like age is a continuous variable, BMI is a continuous thing, and the children is a continuous, and then region charges is a continuous, whereas the sex, smoker, and the region are the discrete variables, which is a categorical variable. So guys, like once we have found and gone through what the data acquisition is, our next and foremost path, it's like exploratory data analysis. Guys, it is very much important to get some predetermined exploratory data analysis. It is way much useful to find whether there exists kind of anomalies, and meanwhile the data is balanced or not, right? So don't worry, guys. In this session, we are dealing with some easy data set where some complex things like cross validation won't come into picture, like imbalance data won't come into picture, or like any other complex things won't come into picture right now. So let's have our exploratory data analysis, which is short from as EDA. Most probably it is described as EDA. So let's describe and see how things are. Okay. Describe. It's my typo. My bad. Okay. So it says like all the numerical variables. So whenever the describe is going on, it won't consider the categorical things. It only consider the numerical attributes, and all the numerical attributes are around 1338 columns. And this count itself shows like this data doesn't have any kind of missing values, which is to be handled, like we have done in our day 6 or day 5. And these are some of the mean values, like on an average, like we have around 1338 columns, right? Among that, most of them were lies in the age group of 39, right? And most of them were at the BMI of 30, and most of them are charged around 13,270, and the variation is around 14 years. And for age, it is like plus or minus 14 of 39, and same it goes on, like it is plus or minus 6, which is 36 or 24. It ranges from 24 and so on. And the minimum age is 18, and the maximum age is 64. The minimum BMI is 15 and the maximum BMI is 53, and so on and so forth. And then 25% of the population were within the age group of 27, whereas 50% of the population were within the age of 39, whereas 75% of the population are within the age of 51. And the same we can give an inference on BMI too, right? So BMI, people within 25% of the population were within 26, which is actually, it's not an ideal, right? So if you are going through our column, you can find like ideal BMI is 18.5 to 24.9. But within by describing this itself, we can come into some business scenarios. Like we can infer some business scenarios, like around 25% of the population were like within 26, which says like some of them, like some of the 25% were not within the ideal BMI, right? And 50% are within 30 of BMI, and 75% were within 34 of BMI. Okay, guys, like once we are done with this, we have you all could find like only we have analyzed the count for the numerical attributes. We have no idea what the categorical attributes are, like is there exist any kind of missing values or not. For that, we have yet another function called info. which help us to find the number of count of non-null values. So you might have found like in both for categorical and numerical, we don't have any kind of null values. Hence we don't need to process the we don't need to handle the missing values, right? So in case you want to learn how to handle the missing values, guys, don't forget to look again the day 5 or day 6 of our intro to ML. We have handled some of the missing values, and hope we have done with the missing values things. And then let's move on to feature engineering. So guys, feature engineering, as I said before, it's nothing but picking up right set of features that influence the target values. It is not always a good practice to include all the values of the columns, because considering in such scenarios, like now we have only 7 columns, so it is not bad to do so. But in case you are going with your in real life scenarios, there are data sets which are around 100 columns, and not 100, all the 100 columns has some direct influence over the target things. So the thing is like we can find what are the features that might be influencing directly, that might have direct influence over the target attributes. Okay, so that's the main aim of feature engineering, right? So let's hop on with that. So here we have feature engineering, right? So in feature engineering, as I said before, we need to figure out what is going to be our features and what is going to be our target, right? So to here it is also important to that we must be we must be good with the spelling of the columns. Okay, so because in case you have a typo of columns, it won't accept. So we can't frame a good thing, right? So consider I'm having y is equal to data dot instead of charges, I assume that it's a charge. It would be throwing an error like has no attribute charge. So this is why it is more important, guys, like to good with the types, with the names or the spellings. So for that, we're using a data dot columns field to list what are the columns that we have for that data frame, right? So upon changing the type or upon removing the typos, like we have ignored our error. And next is picking up the features. So I'm gonna pick random features like age, and then BMI, and then children. So consider like for this day, we gonna just choose these are the values, and we gonna put that into X, naming with data and yes. And guys, like on having X dot head, we will be having only age, BMI, and children. We won't be having sex or smoker or charges. And on printing Y, we'll be having only the charges, right? So along with feature engineering, it is always good practice to segregate the features vectors like test and train dataset or test and val dataset. So the reason is we have already considered in our day 6 videos like what is in sample and out of sample validation, right? So it is always good to have an out of sample validation in our mind. Okay, so for that, as a first step, we have from sklearn, we gonna import a module called model selection. Within that, we gonna import a package called train underscore test underscore split, and we're gonna split into train X and then val X and train Y and val Y. And along with that, we're gonna say train underscore test underscore split, and which is X comma Y comma, we're gonna fix a random state as one. The reason why we are giving a random state one is like irrespective of number of times I'm running these values, I must be getting the same train X and train Y, or train Y, val X and val Y. So that's the reason why we are getting the random, why we are initializing the random state is equal to 1, guys. So in case I'm not bringing in that, on each and every occurrence, I'll be getting different train X and train Y. So let's say train underscore X dot head, we'll be having this one. and train underscore y dot head. And guys, you can see these values upon running this same test train test split with the random state as 1. I'll be getting these same values. Okay, you can see this index numbers has 1043, 968, 594. I'm just running again. 1043 is the same, but in case I'm not giving this random state, right? Now I have 869, 945 on the 1242, and again if I'm running this, the state is changing. So this is the reason, guys, why we are having a random state as it must not be 1, but it must be a constant, right? So we have the random state as 1, and with this we have finished our feature engineering. And once the feature engineering is done, it's all we need to train our model, right? So as I said before, it is always good to have our out of sample validation in our mind. And in model training, guys, in today we're gonna discuss two models. One is decision tree regressor, which we have already covered in our day 6, and next one is our linear regression. So let's hop on. So the first one is from sklearn.tree import decision tree regressor, and model 1 is equal to decision tree regressor, and model 1 dot fit. Guys, like this is most important. You need to fit train x and train y, and not the whole x and y as we might have done in our in sample validation, right? So okay, so the reason is I'm missing the set brackets here, sorry, parenthesis here. Yep, we have resolved it, right? So it is next we gonna import sklearn dot linear model, import linear regression, and model 2 is equal to linear regression, and this time I'm not going to forget the parenthesis, and model 2 dot fit train x and train y, and that's it, guys. Okay, again a typo, small y, right? So that's it, guys. We just have finished our training of decision tree regressor and linear regression. And it is not like once we build a model or train a model, our job is done. It's always good to have a validation that says like, hey, if you are running this one, this is how much accurate your prediction is gonna be, right? So that's where our model validation parts come in, and we have learned a technique called, or a metrics called, mean absolute error, right? So let's hop on and do that. Model validation. So before that, I like to store all these scores and then name of the models in a table, so that at the end of the day, as I'm having two models right here, it would be good to verify. Okay, it would be good to see, okay, which model is performing good or which model is performing better, right? So let me create a compare table is equal to pd dot data frame, and my column is gonna be model and MAE, right? So our table is created, and all we need to do is like after validating, we need to push the values into the model validation. So guys, before getting into model validation, we need to import the metrics first. Okay, from sklearn dot metrics import mean absolute error. So the predicted value of the first model is model1 dot predict. So we here, in case we need to produce x values, and we're gonna store the value in score1 which is gonna be mean absolute error of the actual value. The actual value is nothing but val underscore y, and the predicted value is nothing but predicted of 1. So guys, I made a typo. Yep. So once we are done, it's our duty to push into the compare table so that we can compare on our last phase, so to find which model is a better one. So let's say we have a dictionary called val with the 2 key values. The first value is model, and the second value is MEE. Guys, like, it is always important to have the key name similar to the columns in such a way that these values, the values of these keys, will be assigned to the rows of these columns. I hope I made my point clear. So here we have our first model is decision tree regressor. So we're gonna have decision tree regressor. Okay, and the MA is nothing but score 1. Okay, so with that, I'm gonna append. So it's nothing but it's as simple, guys. With just one single line, we can append the values into a table. Compare table is equal to compare table dot append of val, comma. It's always good to have this ignore index is equal to true. So reason why is like we are just appending a dictionary values. We are not having any kind of index for that each rows, right? So upon this, we have successfully pushed in values to a comparison table, and we are just now validated the values of orders, or the we have just now completed the validation for our linear regression. Sorry, decision tree regressor. Let's hop into the linear regression. So predicted 2 is equal to model 2, guys. Like, it is very much important. If you are giving model 1, we are just predicting the same decision tree regressor and just putting into a different variable, right? So we are just gonna predict the same validation feature, and then we're gonna have score 2, which is gonna be the mean absolute error of the actual value, which is val underscore y, and the predicted value, which is predicted of 2. And once it's done, again we're gonna store the whole thing into a dictionary called val with the model name as linear regression, and the MAE as score 2. And don't forget to push the values, guys. So let me copy this line and then just paste it right here. Okay. So with this part, we have just validated all our models, and then without like, let's let it be a suspense, guys. Like, which model performance is very good when we just stored it into a table, right? So at last, in the final phase of our model training, it's like model selection. So with this model selection, we come to an inference. Okay, this is what I have. This is the model I'm gonna use for rest of my thing, and this is how things works. So the part is model selection, right? So I'm gonna start with our compare table. Yep. And guys, you could see like there is a significant difference between these two models, and linear regression model is performing very good. How am I telling a model is performing very good? Because whenever the value is lesser, it says like there is a less error done by linear regression in predicting a value rather than the decision tree, right? So this is how you compare a model. So in case of considering mean absolute error as your key metrics to validate a models or a group of models, what you do is like you just compare 2 or more models and then validate based on the mean absolute error, and at last you just give an inference like, okay, this is what the model I'm going to use for training. So that's it, guys. From this session, or from this 7 days long scenario, we just start with learning how to write a simple program in Python, and we ended up in learning how prediction works. and how to build an ML model, right from how to acquire a data, how to explore a data, how to pre-process data in case you have an missing values, how to feature engineer, how to select the exact features, how to split a data as train and test plates, how to validate a model, and how to create a model, and then at last how to compare a model, right? I hope this 7-day session you have learned something new. You have learned something new in both machine learning and Python. And guys, don't forget to fill in the attendance form, which is mandatory for your certificate of completion. Don't forget to subscribe and like our channel. And then don't forget to comment in our session. If you guys have any kind of queries, we're happy to address it. Thank you guys. Let me see you in yet another sessions. Bye.